Today we are going to learn about sets. This is an example of sets. A is a set. Whole numbers from 0 to 10 are the collection of objects, also known as members or elements of sets. To get the clear concept of set, first we have to know what is the collection of object and what is the role of objects in this collection. Objects can be living or non-living things in the universe. In the previous example of set A, I have mentioned whole numbers from 0 to 10 as a collection of objects. Objects, when are in the set, they are generally defined by the two terms. One is well-defined term, second is vague term. The whole idea of set depends upon whether a collection is well defined or not. So let's talk about it more. Well defined term. If we can definitely say whether this object belongs to this collection or not. If we are sure, if we are definite, if we are certain about this object that it belongs to this collection, then this is a well-defined term because we can definitely say about it. For example, the collection of players in a team. Players in a team is a well-defined term as we can definitely say, we are sure about it, we are certain about it that these players belong to this team. On the contrary of this, if I say there are good players, there are bad players in a team, then you cannot definitely say that these players belong to this team. We are going to discuss about it in this section, vague term, as this is completely opposite of well-defined term. For example, previously I used the collection of players in a team. As I previously mentioned that players in a team is a well-defined term because we are certain about it that these players belong to this team. But when I say the collection of good players in a team, in this case we are not sure about the good players. We cannot definitely say that these players belong to this team. So this is a vague term, not a well-defined term. On comparing both the terms, well-defined term, vague term, it will be more clear. For example, collection of people in a city. The collection of good people in a city. The collection of teachers in a school. The collection of great teachers in a school. So what will be the well-defined term and vague term in these examples? Let's see. In the well-defined term, people in a city, teachers in a school are well-defined. So these are set. In vague term, good people and great teachers are not definite, are not certain, so not well defined and is not set. After getting familiar with these two terms, well defined term and the vague term, and the collection of objects, it will be very easy to understand the concept of definition of the set. Definition of a set is a well-defined collection of objects is called set. Now we know well-defined and the collection of objects. So now it's clear what is a set. There are few other points that we should remember. One is the sets will be represented by the capital letters, whether they are with A, B, C, Q or any other capital letter. But in case of natural numbers, integers, we have some specific capital letters for those numbers. N is for natural numbers, Z is for integers, Z plus is for positive integers, and so on. Another term, belongs to, not belong to. To show whether an element belongs to a set or not, we got two symbols. This is the symbol for belongs to. This is the symbol for not belong to. Suppose we have set A having elements A, E, I, O, U, all the vowels of the English alphabets. To show whether an element belongs to this set or not, we will use these two symbols. For example, I want to show that A belongs to set A. So how I will write this? A belongs to A. That means A belongs to A. Suppose there is another element named G and it is not in the collection of objects. So how I will show this relation that it doesn't belong to set A? G doesn't belong to set A. G doesn't belong to A. So these are two symbols that specifically used to denote belongs to, not belongs to. Forms of sets. There are two forms of sets. Number one is roster tabular form. Another is set builder form. Roster tabular form. Set A having elements whole numbers from 0 to 10. In the roster tabular form, the set is written like this, where elements are written within the braces and separated by the commas. So we got 2 points here. Second, elements are written within braces, elements are separated by commas. Manner of writing elements in a set doesn't matter. For example, if I am writing elements in set like this, or I am writing the elements like this, whether you write them continuously or randomly, they will denote the same set. Repetition also doesn't matter as it represents the same set. For example, if the elements in the set, suppose if I am writing element A 2 times and then E 2 times, then in the normal way, the set will represent the same set A. Set builder form. Generally, set builder form is all about listing properties. For example, set D having elements from 1 to 8. In the set D, elements are from 1 to 8 and are separated by commas. As we can see, it's clear form of roster tabular form. Writing this same set in the set builder form is quite easy. How? Let's see. Set D, braces open, X is the variable to denote all the objects in the set D. This is the sign for such that. Sometimes you can find this sign with a standing line instead of the colon. So this time I'm having colon as a such that sign. I will read this as such that. X is such that X. Now come to the property part. If you see the collection of objects, what do you see here? All are natural numbers. As previously I told you that n is the symbol for natural numbers. So we will write this x satisfying all the property of n for natural numbers. So are we done yet? No. There is another part of this form. And x is such that greater than 0 and smaller than 9. Now we have listed all our properties in this section, and we have converted the roster tabular form of set D into the set builder form. You can try it in another example. D having elements 1, 4, 9, 16, 25. What pattern do we see here in the collection of objects? I think the pattern is this square of natural numbers. We write x in the set to denote all the objects in a set. But here, what do you see? Each object, each element having square. So what we do here for this? We simply make x square. So it will represent all the elements in set D. And what are these numbers? These are natural numbers. So we will use n again for the property part. So how we will write this? Set D, braces open, x is such that x is satisfying property n and x square, as this is our next property, x square is less than 36 braces closed. So this is our set builder form where x is satisfying property n, or in general form we say property p. Definition of a set builder form. After understanding what is property and how to recognize it, it's very easy for us to understand the definition of set builder form. Set builder form is listing of properties, as we did earlier. We listed properties satisfied by all the elements of the set. As we can see it very clearly, D, x is such that x satisfies all property n and x square is less than 36. So within the braces, what do we have here? Listing of properties. These are listing of properties, and this is our set. The set of all those x such that each element has properties p. This is set of all those x such that each element, as this x is denoting each element, has properties p, that means n. Again, the set of all those x, the set of all those x such that each element has properties n, properties p. So it's very easy now for us to understand what is the definition of set builder form. Now you can write or try any question yourself to know this concept better.